All right, and now we're going to do taste and smell, and it is going to be a really, really quick one, okay? So when it comes to taste, probably when you were young, you learned there's 4 basic tastes, but there's actually 5. A new one has been added. So we have sweet, salty, sour, bitter, and then we have something called umami, which is like a savory, proteiny flavor. So like think meat. Meat has an umami taste. Anything that is savory in nature has this taste. Come on. All right, so when we think about the sense of taste, we call it gustation, and gustation is a chemical experience. So we talked about the eyes having light waves, and then sound having sound waves. Taste and smell are both chemical, and then touch is a physical sensation. So this chemical sense is picked up by taste buds, and I don't think you need to know numbers because I keep seeing different numbers for everything, but here's the deal. When you look at your tongue, if you were to stick it out in the mirror, you can see little bumps all over it, right? Especially in the back, they're actually like raised. But even at the front, you can see like patches with circles. These bumps are called papillae or papilla. And inside each papilla, you have their taste bud. So each bump is not its own unique taste bud. Those are papilla, and then you have a bunch of taste buds housed in each of those bumps. So if we zoom in. All right, so with this, and when it comes to taste receptors, they absorb the chemical of whatever you're eating, and then your spit dissolves it so it can soak into your taste bud. Once that taste is there, the taste buds will trigger it or turn it into a neural impulse, sends it to the thalamus, and then it's processed. So we've talked about how you can't damage your receptor cells for your eyes and your ears, right? Like if you hurt your rods and cones, that's it. If you hurt your hair cells, we can't fix those. They're gone. But with skin, remember, you can, like, your skin cells are always shedding everything you do. If you were to cut your skin, they kind of grow back eventually to some extent, depending on the damage. With taste buds or taste cells, they actually replace themselves every 10 days. And then sometimes we hurt them too. Like if you've ever eaten something that was way too hot and you burned your mouth, yeah, you can't taste very well on those parts of your mouth anymore because your taste buds are gone, or your taste cells. And they have to regrow, but they have the ability to do that, which makes it really unique. Now, different people have different taste abilities. We have super tasters and we have non-tasters, which if you look at the pictures here, you have a super taster here with all of these buds collected really tight. And then we have non-tasters, and we have people that are right in the middle that are called average tasters. So we're going to look at each of these slightly, and then I posted a video on the stream that you can watch too about super tasters. So, super tasters, these people have an abundance or a lot of papillae on their tongue. So if you go look in the mirror right now, or if you want to do the experiment, you need to find some blue food coloring, take a swab, paint the tip of your tongue, and then like take a drink of water to wash some of the blue out or swallow a couple times. And then if you stick your tongue out in the mirror, if your tongue looks like this, you're a super taster. If it's less sparse, normal taster. If you don't have many bumps there, you're a non-taster is what they call it. You can still taste, it's just less, it's more mild. So about 25% of people are super tasters, and they're a lot more sensitive to things that are bitter. So things like broccoli, tea, grapefruit, even like coffee, alcohol, all those things taste more bitter to them. I don't know if some biology classes, maybe AP Bio still does it. You can get this paper that you put on your tongue, and if it tastes bitter, you're a super taster. If you are a normal or a non-taster, it just tastes like you're sucking on a piece of notebook paper. More women than men actually are super tasters, and people who are super tasters have a stronger sense of smell, which makes sense because, as we'll talk about it, like I think it's like 75% of taste is due to smell. So people with minimum taste receptors, about 25% of the population, are called non-tasters. It's not that they don't taste, it's just less intense. So things that are bitter don't bother them as much. You know, it's just there's a lack of intensity there, which isn't a bad thing. And then you have 50% of people that would be considered a normal taster. So I can't have you watch the video on here because it won't record sound, but I did post it on our stream. And so it's a super interesting video because it talks about like pain receptors in your tongue and how if you like spicy food, it's actually because it's lighting up your pain receptors. And so typically people who are super tasters are more sensitive to spicy foods because they have more papillae and more taste buds, so more pain receptors. And so when they eat something that's mildly spicy, it seems more intense than somebody who would be an average or a non-taster. Non-tasters can probably eat really, really spicy food because they're not going to pick up on it as much. So they talk about that. They also talk about how, like, pain management. If you have sores in your mouth, you can do these things like burning out your taste buds with eating something super, super spicy, and it numbs the pain. And they paint his tongue blue and like do that too. So I would highly advise watching it. It's really entertaining, and it's super cool, especially if you like spicy foods. It kind of goes into more detail about it. Something I always have kids watch in class, but we're not there. All right, now sensory interaction is something that we talk about this unit because all of our senses interact with each other, right? So if I smell some food and it stinks real bad, I'm not going to want to eat it, and that's a sensory interaction. I don't want to eat it, or I don't like the taste of something because it smells real bad. Or texture in food. I'm a texture in food person. Like, I like the flavor of a banana, but I absolutely hate the weird, slimy, mushy texture of a banana, so I won't eat one. But if you blend it up in a smoothie, great. A lot of things have to do with vision, too. Visually appealing things. So in kindergarten, they usually read like green eggs and ham and then make green eggs and ham for the kids. And a lot of kids won't eat it. Or even looking at that picture, I do not. It looks like maybe super chunky guacamole or something. But if somebody told me those were eggs, I might not want to eat them because they look weird to me. Same with Heinz for a while did this purple ketchup. And it was supposed to be super cool, but look at that picture. It's not appetizing. I don't know what kind of purple goo somebody put on my food, but it's certainly not ketchup, and so it didn't sell really well. So all of our senses interact with each other and really affect our behaviors. So when we look at smell and taste are always doing the sensory interaction thing. They're always going hand in hand with each other because 75% of flavor is smell. And what this is like, think about it. When you have to eat something gross, you always like plug your nose to eat it. Or if you have a cold, nothing really tastes that good. Maybe because you're sick, but it's mostly because nothing has flavor. It's not appealing to us at all. So we have to have these two things interacting to make like this awesome flavor combo. So then we'll tap onto smell. We don't have much to say about it. Smell is still a chemical sense. We've talked about the olfactory bulb up behind where your kind of nose and your eyes meet at the base of your brain there. It's going to be the place where when you sniff something, it goes and it clings to your olfactory bulb in the very like back of your nose kind of, and then it goes into your brain and tells you what you're smelling and if it's like a good smell or a bad smell, right? And so our olfactory cells are actually located in our nasal passage, and they're the blue things dangling here from our olfactory bulb. So they dangle down, and that's why if you look at this picture, let me move my picture, hopefully that works. When you sniff up, it's not right here that you smell. It's all the way back up in your nasal cavity. So that's why when you're trying to smell something, you go and you sniff real hard. You're trying to get the air up into your nose to be able to get what you're smelling. So what actually happens is, this is like a long-winded thing, and we're just going to simplify it here. If I want to smell a flower, the reason why I sniff so hard is because I have to get the air and the particles coming off, like the actual like chemicals coming off that rose that produce its scent. I have to sniff it up and swirl it into my nose with the air, and that's why I sniff. And it goes all the way up my nose and swirls till it gets to my receptors up there. And then my olfactory bulb can send it to my brain and process it. So smell, another chemical sense, strong sensory interaction with taste. And then the last two senses that we never really think about are the kinesthetic sense, or kinesthesia, and then vestibular sense. So the kinesthetic sense is your body position without having to visually look at it. So if I am trying to walk through a room and for whatever reason, I'm twirling my arms around as I'm walking through. Like right now, I know where my curtain is over here and where my desk is. And so I don't have to watch my arms. I know where they are in space. So I'm not like knocking my computer over and pulling the blinds down, right? I know where it is in space. I know where everything is without having to visually look at it every second. I know where everything is on my body. And then we have the vestibular sense, which is all about balance and body position, not body placement as far as like where my body is in space. It's what is the orientation? Am I upright? Am I sideways? Am I laying down? Am I upside down? And this is because of those vestibular, the semicircular canals and the vestibular sacs. So when I told you if you spun around in a circle and we did the ear, you'd be really dizzy because of water sloshing. Well, if I lay down or I'm laying like this, the water or the fluid in my semicircular canals is like off to the side of the loops now instead of I'm right side up. It can know that. So think of if somebody put you in one of those weird spinny gyroscope things, you could be blindfolded and you would still know if you're upside down, sideways, at a 45-degree angle. You would know all that without having to see because your ears are letting you know with the semicircular canals and vestibular sacs. This is what allows that to happen. And it also, you know, not only is it body orientation in space, but it's also your sense of balance too. So hopefully this lets you know that instead of 5 senses, we actually have like 7. But yeah, I think that is it for this lecture over the missing senses, right? And so that's it. We're going to go on to perception from here. Now that we have how your body picks up the senses, it's going to be all about how you perceive stuff and maybe how you misperceive stuff. So, all right. Thanks for watching.